welcome to another Great Cow BASIC tutorial. This is part 2 for the PIC18FxxQ41 family of chips, and today we're in part 2, so we are going to make some LEDs flash in sequence. Let me just go through how we're going to do that in terms of the hardware. So we're using a microchip low pin count demo board, the green thing on the left there. I am hopefully going to get some Curiosity demo boards from Microchip. I asked them yesterday. Hopefully they'll be through before we get through the end of this these sessions. Let's have a look at one of those, what it looks like. It looks like this. This is the board, and it's got 4 LEDs and a pot and a switch. What does that look like in terms of the layout? It looks like this. You can build your own. As I showed you yesterday in the first video, there were many different types, but this is done by Chris Roper. It's a really good layout, and we are going to make these 4 LEDs flash in sequence. Now, yesterday we just turned the LED on and off, so today we're going to make that a little bit more advanced. So what we're going to do is make 4 LEDs flash, and we're going to initialize the chip initially, the board. Let me just bring a pen up. We're going to initialize the board, and that means Great Cow BASIC will set up the frequency, the ports, inputs and outputs, etc., etc. It does that automatically for you. We're going to set the first LED to a particular state, and we're going to wait, I think, 1 second. Then we're going to rotate the LEDs, which I'll peel that back for us in a moment. And then we're going to figure out whether it overflowed. We'll look at the overflow status, and then if it did overflow, it will, if it doesn't overflow, sorry, it will go back and have a delay and come around this circle here. If that, but if it does overflow, then we'll set the LED and return back to the delay. So it's quite an easy sequence to do. But what does it look like in reality? Well, it looks like this. We're going to use something called, we're going to set the values of the LEDs to on or off, but we're going to use a little special register called the carry, which is sitting out in a register, and we're going to actually test for that. So we're going to set one, then we're going to set the next, set the next, set the next, set the next, test for this particular carry state, and then if it is, just restart. So what does that look like in terms of some sort of a diagram? This is what we're going to do. We're going to set LED 4, which is on port C3 to 1. If you look at the top right hand corner here, you can see there's an LED state, and we'll see that in a moment. Then we're going to move that along by rotating a variable, so it will set our next LED, then our next LED, and then our next LED, and then the next time we do a rotate, it will move it into the carry flag. And when it moves it into the carry flag, we can test for that, and then we can restart our sequence back at C3, which means back to where we started, so it will continue. In terms of a flow diagram, I have a flow diagram which I'll show you in a moment, but we'll pull that out and look at the lab. Okay, so here we go. We got some. I've got my desktop all set up, and we'll zoom in on we'll zoom in here on the editor so we can see what we're doing now. All settled, and we're going to be looking at some code now. All right, so we saw this yesterday. We saw how to set the chip up. We just specified the chip name. We're going to be using the default frequency, so you can change this here and have a little play. You can put a comma behind it, and then you can see all the valid frequencies. And I think this is quite a wide-ranging chip. So if I look in a utility that is available, we can actually determine that. So tomorrow we'll look at how we actually determine these values. Then I use option explicit, and that means I have to define all my variables. Well, all the green stuff is important because it's commentary. And today what we've got is 4 LEDs attached on port C on bit 0 to 3. There we go. And I'm going to call those, they have names. They're called RC0 to RC3, and I'm going to set the direction of those ports to out because we need them as outputs. And then I define a small little macro, and that macro sets the RC, we'll do it in reverse order, RC3 to 1, and the others to 0. So the initial state will be RC3 set to 1, which is really simple. And if I actually run the code, it will actually then load those states in for us. Now, we have on this board a full port, and that full port is made up of 8 bits. So I just need to mask off these bits that I'm interested in. I'll explain that very shortly. So here we go. We have a set the initial state using that little macro I wrote at the top there. If I click on it, I can see it, and then it waits for 1 second. So it sets it to RC3 to 1, which means that the first LED will come on, and then it will wait. I'll show you why I've done that. It will wait for 1 second. Then it sets the C off. This is the carry flag. In Great Cow Basic, we call carry C, and then I rotate the port. And that port is the port C, so it will rotate it, and it will do exactly what we saw in the diagrams. It will move 1 bit to the right. Okay. Then we can see if the carry is set. If the carry is set, we then know to set our initial value. And because we might have more than 1 port active, we might have things hanging off this. We've only got these 4 LEDs. I just mask them off, okay? And it just cleans, it keeps it nice and clean in terms of the code. So if I make a hex, I've got it all set up. I can then see that rotate through, and it will rotate the LEDs through. It's programmed it, waited 1 second, waited 1 second, waited 1 second, and back. So it's now rotating through the LEDs quite nicely. So at this point here at the end, we've detected the C value is set, and then we take it back to the beginning. Now, the important thing about all this is that you can see this for live in terms of doing this yourself, but what you can do in Great Cow Basic, you can actually see how this is actually happening in assembler. So if you go into the IDE and you select show ASM or press Shift F7, you'll end up in the assembler. And here is the actual assembler being written. It's all fully documented for you, and you can see exactly what it's doing here. So in assembler, which will only do this once, is you can see it's setting the certain bits to it's clearing them down to make them an output. It runs our little macro. It waits 1 second. Here's the wait 1 second, which is fine. It then it sets the carry flag, then clears that down. It rotates the port. Now, because Great Cow Basic is what's called portable code, you can do this on many different chips without changing the actual program. But our back-end assembler will change that for your specific chip. And here we have the rest of the program shown, and then the rest of it beneath it is assembler. Now, what is interesting about this program, that has taken, let's have a look, it's taken 89 words of program memory and 0 of RAM, which is wonderful. Is that true? That's absolutely incredible. That's right. And then what I've also posted in the demonstration code is how you can do exactly the same in a raw assembler. Okay, and here this just proves this once in these tutorials that you can actually use Great Cow Basic with assembler. So I've defined the chip exactly the same at the top. So I've defined the option explicit, defined 3 variables that are required, and then I've actually got the same code. Now the difference here is that you have to set everything up, and it is not portable code. This code will work on this chip. It will work exactly perfectly. It will do a delay of 197 milliseconds, which is expected to do, and that code uses 3 bytes of RAM and program memory of 49 words, but it's not portable code. The beauty of Great Cow Basic is portable code. So I'm just going to change that to 197 milliseconds because I'm now in my basic code. I can now, you'll see that rotate exactly the same as in the assembler. There we go. So today we wanted to rotate some LEDs. I've also shown you that you can use Great Cow Basic to use assembler, but you won't be creating what's called portable code. So if I take the exact same code in Basic and change the chip, this code will work. I think we should do that. I've got a a 16F something or other here. I will just plug that in. We haven't programmed it yet, so let's just determine what chip that is in there. The chip that's in there is a 16F, so I'm just going to change in our program to a 16F18446, and I'm going to program it. And trust me, there is no trickery going on here. That's portable code, and now it's generated it for that particular chip. I'll revert that, try and program it, and it will fail because it hasn't got the right chip in it. So back to our board that we're using, because I need that for tomorrow's session. So we wanted to look at setting 4 LEDs. Well, tomorrow we're going to look at setting the LEDs to represent the value of an ADC port, which is on that board, that blue pot, and we'll do that tomorrow. So with that, we'll call that a wrap.